Hello everyone, I'm Callum at Repair Wins. Repair Wins is an electronics repair business, and in this video you'll be seeing no repair at all. Instead, you're going to see some refurbishment and some repurposing, because I'm going to turn this generic computer case and this generic motherboard into a NAS. Now, if you don't know what a NAS is, it stands for Network Attached Storage, and it's pretty much like the hard drive inside your computer, but it's somewhere else in your home or your office, and you can just connect to it over Ethernet. It isn't going to be a simple case of just dropping the board into the case and calling it a day though. I'm going to need to drill some holes in the bottom of the case, so I've got room to mount extra hard drives. I plan on taking this power supply out to use it elsewhere, and I'm going to install a different one. I'm going to need to snip some of the connectors off and then replace them with extra SATA cables so we actually have enough, and I'd like to get some fans put inside the case too. And then after I've done all of that, I'm going to install openmediavault. I'll show you how I set it up, how we get a RAID 10 configuration going, and it's pretty much going to be a full walkthrough with a bit of modding in the middle. So let's get on with it. Our first order of business is to install two of these motherboard standoffs, because even though this used to have a Micro ATX board inside, it's smaller than the one that I'm putting in. So I've already done the one, you can see it down here, and I'm just going to do the other one. A motherboard standoff is one of these brass things, by the way. The idea is the motherboard screws into it, and I'm going to put it right here and just screw it down. And then that's going to go into place, going to tighten it up nicely, and there you are, look, now I have an extra place to mount the motherboard. The next thing I'm going to do is remove the power supply. So the power supply is this thing down here. It's sort of a square shape, and it's got all the wires coming out of it. Now, it's a completely standard unit, so you might be wondering why I'm removing it. The reason why is because it's a standard unit, it can go in another computer, whereas I have one that is a bit of a funny shape, but it'll fit in here after I've 3D printed a bracket. So that's what I'm going to do. I'm going to 3D print a part to fit a different power supply in here, and then I'll have this standard unit which I can use elsewhere. There you go, look, I've just taken the 4 screws out, so now the power supply will slide out like this. And obviously when you're doing something like this, make sure you're nice and gentle. You wouldn't want to nick one of the wires on the side of the case. As you can see, then I have this unit here. It conforms to the same outputs, so it's got the same 24-pin connector, it has the same CPU connector. You can see I've obviously modified it in the past, but I'm going to be making yet more modifications to it today so that I can have 5 of these SATA connectors, 1 for the SSD and then 4 for the hard drives. And the power supply has got more than enough power for that because it's an older unit built back when computers weren't as efficient. Anyway, you can see that this unit is clearly far too small. It's designed to go in one of those slimline cases, but I can 3D print something that screws in here and there, and then has pretty much 4 more mount points to screw in, so that this will fit in this case just like it's a regular ATX power supply. And there's absolutely nothing wrong with doing that, by the way. It'll work perfectly fine, and it just means that I can use this old worthless power supply instead of the slightly newer one that's got a bit more value. There's already an SSD in this case, but unfortunately I can't use it. Pretty much, I was able to take the case home, but they need the storage back, so I'm not going to argue with them. I'm going to take the case, and they can just have the SSD. Not really an issue, because I've got this spare one right here, and to be fair, it's been sat on the shelf for the last year, so I'm not charging my friend any money for it. I'm just going to drop it into the case, and he can just have it. Right, so make sure it's screwed in nice and tightly. We don't want it to sort of vibrate or whatever. And now that that's done, we're going to flip the case around, because there's actually 2 more screws on the other side. So I'll do this one, and then I'll do the other one off camera because it's hidden under here and it's quite tricky to get to. I can just about show you the process of me putting the side panel back on. So we'll just slide it over. And then this case is quite nice because it's got thumb screws for everything, so I'm just going to screw it down. There we go, brilliant. This is what I've come up with. So you can see it's just a 3D printed plastic part, goes over, doesn't cover any of the vents, and then 1, 2, 3 screws, and then obviously it's got provisions for 4 more to go in the case. Only problem is I accidentally flipped the entire thing in the software, so this screw hole is in the right position, and so is this one, but these 2 aren't. Not the end of the world. I'll just screw the bottom 2 in, hold this in place, and then use a drill bit to put the other holes in the right areas. Here we are, look, I've screwed it in, nice and sturdy. Just need to put this in the case. I've brought the supply up into place, and I think you can more easily see the issue now. So this one lines up, this one lines up, these two don't, because you've got a hole right here, and then this one's obviously no good. So yeah, like I was saying, I'll just screw these two in. Just using standard M3 screws like you would with any other computer case. And then this one hasn't been done before, so this is going to be quite difficult. There we are. So 2 of them are screwed in. It's clearly only temporary, but that will do for now just to hold the thing in place. Happily, I've managed to find a good camera angle so you can actually see what I'm doing when I drill this hole here and that one there. I'm going to be drilling it using this 1982 Black & Decker drill, made in England before Black & Decker went to crap. And despite the fact that the drill is 43 years old as of the time of recording, it works with no issues whatsoever. In fact, if anything, it's really bloody reliable. This will be fairly loud, so I'll mute the clip. But I'm going to sort of just put the drill right here in the centre. I'm going to hold down on the plastic from behind so it doesn't shift about. And then yeah, we'll just do this thing. That's literally all it takes. What I've realised I can do is hold down here from behind, and then I can now do this one without much fear. Again, it's a flipping loud tool, but my god does it get the job done, even with my rubbish old blunt drill bits. That's perfect, they're both where they need to be, so I can now screw them in. There you go. I thought I'd show you these because they already exist in the real world. I'm going to print off some more of the same brackets, and then what we'll do is we'll line them up in the case, make some marks, drill the holes through and screw them down. Here we go, the pieces are finally finished printing. It took about 4.5 hours. As you can see, I printed them on something called a raft. And as the name implies, a raft is pretty much just something that all the prints sit on top of. The reason why I used a raft is because these are tall prints and it took quite a long time to print them all out. I didn't want to run the risk of them detaching themselves, you know, from the bed, because if they had, that would have been a disaster. Either way though, they look decent. It's time to break them off of here and then we can get them installed in the case. To remove the prints from the rafts, all you have to do is just literally bend down on it and it'll just break off. It's quite satisfying, and look at that. Not perfect, this one has some sort of a defect here. No idea why that happened, but either way, it'll stick fine to the bed. And then I'll just do the same for the others. The plan, I'll stand the case up so you can see what I'm talking about, is to put one here, one on the other side, one here, one on the other side. We'll drill 3 holes, 3 holes, 3 holes, 3 holes, and that will allow us to put some screws in through the bottom into these pieces, and you can see the case has got these nice tall feet on it, so it's not going to be an issue. In the same way that I did for the power supply, these need to be drilled out. So I've loaded a 3.5mm drill bit. I'm going to hold this into here. I'm holding on fairly firmly, and I'm just letting the weight of the drill do the work. I'm not pushing down, because otherwise it'll end up breaking through at the bottom. The drill bit will go through and it'll jam in at an angle and it might snap this piece off. So just don't be impatient, just hold on to it like this, hold in firmly, and then I'll just start the drill. That's all I'm doing. And then you just pick this sort of piece off here, although that's obviously a lot easier to do when you're not doing it one-handed. A little bit precarious this, not always safe, but just a bit of common sense goes a long way, I think. See what I mean? You see how the drill bit got pulled down in? If I'd been forcing down on that, it might have gone all the way down and broke this piece off. And then for the last time. There we go, that's all there is to it. Then just grab the bits of rubbish, flick them away, we need to dry fit the motherboard in order to find out where we can put the rails, because if I hold the motherboard over the top, you'll see that it hangs quite far down here, and I want to make sure the hard drive rails aren't going to collide with the board, otherwise this whole project, well, basically it's finished before it even gets off the ground. So I'm just going to take the screws out. I'll hold the wires of the power supply out of the way, and then we'll just basically lower the board in. Kind of as I feared, the motherboard is all the way over here. Some of them are a little bit shorter, I think. I'm pretty sure. I know they're certainly shorter in this dimension. They might not. This might be sort of, because there's two Micro ATX sizes. There's one that's this full-size square, and the other one is a rectangle that cuts off this top bit. But if I grab our rails, there should still be room for the hard drive to go here, and then maybe for the other one to go all the way above it. I think it'd be a tight squeeze, but it can be made to work. The board would have to go in first though, and then the hard drives would be lowered down in the caddy and held in place, and screws put through from the bottom. So not perfect, but we are retrofitting this stuff into an old case. Either way, I think this will actually work fine, and then I can just move the other one down. But I want to make sure I don't block off access to all my SATA connectors, because if I put it here, then how am I supposed to plug the drives in? So unfortunately it's not going to go there because there's not enough room. So I guess we're going to have one here, one there, and I'll just be careful with where I put these things, because you can get flat SATA cables, but I don't want to make it an absolute nightmare just to get anything in or out of this case. We may have hit a roadblock here. You can see that this fits, but there's microns in it, like there's so little room. I mean, we do have access to the SATA connectors, and if I shift this back just ever so slightly, we'll have access to all 6 of them, so that's fine. But what about the hard drives that go at the front? And then we'll need a fan as well. So I'm thinking I might just 3D print something to use the 2 unused DVD drive bays instead. Has thrown a bit of a spanner in the works though. Luckily I already had this bank of hard drives spare from earlier, but I think this is how I'm going to do it. I'm probably going to have these 2 hard drives here, we'll have a fan there, and then the other hard drives here. I might be jinxing myself, but I don't think it's going to be too hard to drill through in order to put the holes in the case. So you see there's a rivet here and a rivet there, and on the inside of the case the rivets actually line up almost perfectly with the tops of these hard drive rails. So all I've done is I've just lined them up, put a millimetre between the rivet and the rail. I just need to firmly hold the hard drive in place and then drill the 4 holes. As you can see here, I've started the hole off. I've got this piece of plastic from earlier, which is just going to go inside the case to completely cover the intake fan on the power supply. And then I've also got a hoover next to me. So I'm going to be running the hoover while I push down with the drill, and then that way we're going to soak up all the metal shavings. And this is a hoover that's rated for metal. I'm not just sucking this up with your generic with a generic hoover that's going to go bang as soon as it gets a shaving inside. It'll be absolutely fine. And luckily I've only put a tiny mark in the bottom of the case here. Now that's nothing a bit of black Sharpie won't fix, but you can see that's nice, that's decent. So I just need to do that 3 more times and I think we'll have gotten somewhere. To make life easier, I've put a screw through from the bottom, and then holding firmly down on here once more, I can then start this one off. A bit shaky, but that's all I need to do. The hole is once again started off. And obviously I'm not going to punch all the way through because that might cause issues. So once again, I'll just grab the hoover, absorb all the filings, and then we should be good to go. I'm very pleased with that, I've got to say, very pleased indeed. You can see here, 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 and there, they all line up pretty much perfectly. In order to install the hard drives, I'm going to use one of these called a bolt and one of these called a wing nut. And the reason why I'm using wing nuts is because they're a lot easier to hold on to and then twist into place. And given I really don't have much access, I think a wing nut is the right choice. So all I'll do is just lower this in. I'm going to place it where it needs to be. I can push this through from the other side. Right, there we are. So that's lined up. And then I'll just do the other one. Right, good news, these 2 actually line up, so we're not in a bad position. I'll hold this here, and then I can put the wing nut in. And like I say, it's fiddly, but at some point it all just lines up, look, and then there you go. I can do the same to the other side. Boom, now I'll just tighten down. So that'll hold itself in place, sort of. I'm obviously going to need to hold here because there's nothing supporting these two. And then to get these two in, I'm just going to use some thicker screws, and then I'll just tighten them directly down into the plastic instead of trying to, because there's just no access at all to use a nut and a bolt otherwise. But yeah, now we have a caddy that's secured in place nicely, and the motherboard fits. I'm really not too displeased with that actually. Come up with a solution to mount all 6 drives. We obviously have 2 here, the SSD. It turns out we can get 3 hard drives here. I only thought we could do 2 with these holes, but nope, you can put a 3rd one here if you want. And then we'll put a final one at the very top, and we'll leave this as a gap, because that way you'll have room for a little bit of airflow between them. And also the wires that the front panel has, you can see a bit of a rat's nest back there. So we'll have access to run all the wiring, and we'll be able to connect all 6 hard drives. And as a bonus, the motherboard has a connector for the fan down there. You see that red connector? And it has another connector over here. You see that other red connector? So we can even have a fan at the front and a fan at the back. Everything will be nice and cool. The power supply will be able to manage, and we'll have all the hard drives that we want. I thought I'd hold on to it to make it really obvious what the issue is. But look how long this CPU power cable is. I've got no idea why it was designed like that, because I can't think of a case on earth that would need a wire this long. But either way, what I'm going to do is I'm going to cut out some of the excess. So chances are I'll just snip here, I'll snip there, and we'll just jump this directly over. Probably makes sense to keep one end long and then cut the other one quite close to the unit, because otherwise your heat shrink, you struggle to move the heat shrink down without actually having it shrink when you don't want it to. So I'm going to snip these 2 about here, because you see this is just going to run directly to there, look. And then there will be a bit of overlap. I don't want to cut it so far that it's taut, but if I just come back a tiny bit more and cut that there. Now we've gotten rid of all this unnecessary length, and this is nice, thick, high quality cable as well, which means that we can reuse it elsewhere. But now I just get these 2 wires, I can splice them together. I get these 2 wires, I can splice them together as well, and then we can splice this directly into here, and happy days. If you don't have any automatic wire strippers, I highly recommend you get a pair. All I do is I put this on, pull back on it, and then there you go, look. I can then twist these 2 wires together, because we're going to solder them both at the same time. So you just grab on, twist the copper, although in this case I actually think it's aluminium, but either way you twist the wire, and then that's together, all good. If you don't know how to solder, there's a really, really good video on YouTube by ChrisFix. If you've not watched it, then go and watch that. But all I'm going to do is twist these big bundles of wire together, then you'll end up with this big sort of lump in the middle. And I'm not confident the heat shrink tubing will actually be able to get over that, so I'd best just check. And no, it's not even going to be close. Let's just split these apart then. I'll remove the heat shrink and I'll put a bigger piece on. But all I need to do is just unravel some of the solder, and then I'll put a bit on the iron. And then I'm going to just start at the top, flood solder on, flood solder on, flood solder on. Eventually it'll start wicking into the metal. It's a lot of metal, by the way, to heat up, so it does take a while, but that's slowly starting to wick. And then I can come in from the other side now. And then it does get rather smoky. Right, at any minute now this big glob of solder is going to absorb. But I'm going to keep going, keep going, keep going. We're going to flood loads of solder in. I want this to be a really solid connection. And then I'm going to back away gently, because there's a big solder ball on the end of this iron now. Right, I've increased the heat of that iron to 395. You can see that the insulation's a bit melted, but it'll be alright when I slide the heat shrink up. As you can see then, I've slid the heat shrink over. I've got my hot air station. It's at maximum airflow, 250 degrees Celsius. And all I'm going to do is just heat the heat shrink, and as the name implies, it will shrink down. I've soldered this one up as well, and I'm just going to put the heat shrink on. There we go, these 2 are soldered up. I've put a zip tie around here and they're in place. All looks good. I put a couple zip ties around the main 24 pin connector as well, and that way it makes it easy to identify all of the other wires. I'm afraid I wasn't able to show you me modelling the part, because pretty much I don't have a setup that allows me to record what I'm doing, but I'm 3D printing an I/O shield that I've designed for this motherboard, and in 25 minutes or thereabouts it should be done. This is a really quick printer. I've got the first I/O shielder printed off right here, and it looks really nice, but it didn't quite fit properly. The ports didn't line up. If I show you the second one that I've printed, it fits way better. There is still room for improvement, obviously. So a third model, and I should have it looking exactly the way it needs to. This is my third go, and I think I'm going to leave it there. So you can see it all fits in place nicely. There's a few small improvements that need to be made, and I'll make those and then obviously save the files, but I'm not going to print another one because time is of the essence, and this is only a NAS at the end of the day. But if you go on Printables and download this model, because I'm going to put it there for free, then it will have the tweaks made. Whilst I'm here, I'll just plug in the CPU power, run that to about there, and then I'm going to plug in the motherboard power as well. And we can sort of zip tie that up here, which keeps it out of the way. It keeps it out of the way, so that way it's not going to impede airflow. I've done a bit of work off camera, so you can see I've zip tied that into place. I've been a bit creative to zip tie this down. Unlike before, I'm just going to solder these up one at a time. So I'm going to get my yellow, I'm going to get my other yellow, and you can twist them together like so. So that's pretty much the same thickness as one piece of wire. And then I've got this really handy 3D printed piece that just lets me put the wires in each side. The soldering iron, I'm using that same rubbish solder from earlier. There you are, you see there was absolutely no trouble doing that at all. I'm quite pleased with that, and it didn't even take 5 minutes to do, look. There we are, 4 nice quality solder joints. Throw one zip tie on here and we're away. I'm having to pull out some pretty sophisticated techniques here. Pretty much I've stripped this back, except I haven't really because there's loads of length left. Because the plan is for me to splice in this kind of in the middle, and then this wire will carry on because more needs to be spliced onto it afterwards. The way that you make it work is by setting this up way shorter so it can go all the way to there, but you set it up pretty much at the start. Then you just strip the 4 of them back as you would. And what I would like to do is to take this one for example, and I'm just going to spin it sort of around here. Try my best to twist it up. Doesn't really work as well as you would ever like it to, but I can twist that up like that. We'll sort of push them together, leave everything dangling. Then I can just solder that, and you'll notice that I've put a piece of heat shrink tubing here, so that when that's soldered you just slide it up and it covers it. I've soldered the first connection off camera. Now that I've done that, I'm a bit more familiar with the technique because it's been quite a while since I've used it, so I'll set the camera up overhead and get the other 3 soldered. Hopefully it's fairly obvious what I'm doing by now. I'm just grabbing the wire, looping it under, and then sort of wrapping it around, and then when I've wrapped it around I kind of twist it back on itself, so you end up with this ball of wire here, and then I'm just flooding solder into it. And I'm obviously taking a bit of risk because I'm soldering directly over the motherboard. I'd recommend you find something to put in the way, or you just take the power supply out, but I've soldered enough times that I'll be alright. All that's left to do then is I turn the hot air on, I slide the heat shrink down, and we just shrink it into place. And we always just seal the deal with a zip tie. You can see the end result then. We've got this little contraption here spliced into the middle, and then we can just run these directly into this bundle of wires here. I've stripped the insulation on these 2 wires back, so I'm going to twist them together now. And then what I'll do is I'll strip the insulation back on here, the yellow one specifically, because that carries the 12 volts. I'm just going to put some heat shrink around it, and then when the heat shrink is on we'll be able to solder this together. I'm pressed for time, so I did the rest of the soldering off camera. Not the prettiest. Tech Yes City would say it looks like a jungle sandwich, but I don't really care because they're all solid quality sturdy solder joints, plenty of heat shrink tubing. The stuff's zip tied down neatly, at least as neatly as we can get it in this case. The USB 3 isn't plugged in because there's nowhere for it, but it doesn't matter because we still have the USB 2 plugged in, and last time I checked there's plenty of ports on the back. Not that they're really going to get used anyway. We've done the front panel power, we've done the audio, And then all of the SATA connectors are now soldered on, and it's a little bit convoluted, but they can all plug in, so that's fine. There'll be access to 4 of the SATA cables, like, you know, for the SATA data, because 2 of them get kind of covered up, but that's okay because he was always planning on using a PCIe card. These 2 things here, so they're obviously going to go down in the bottom of the case, as you've already seen, and then these 2 that you haven't seen yet, so they go sort of face down like that. Obviously it'll be on the inside, not on the outside. One here, one on the other side. These bits screw into the hard drive, that bit screws in to the top, and then that'll hold down a 3.5-inch hard drive nicely. It's my own design. I refined it over like 10 goes. It uses as little filament as possible, but it's still nice and sturdy, and it prints really fast. As usual, if you need it, there'll be a link on printables. I've got good news. I managed to find 2 90mm fans. That's really going to help because this case is going to be quite full. Remember, 2 hard drives here, 3 hard drives here, a hard drive there, and an SSD. But a little trick you can do is to wrap the wire around the fan, because these ones are ridiculously long because they came out of an old Lenovo office tower. I can put that there and run this wire down, look, and then that way we've not got a silly amount of length. So I'm just going to plug this in now, and they only go in one way so you can't do it wrong. But that's plugged in like that, and then this can go into place, and it's got just enough length that it'll plug in comfortably. And I know that when my friend comes to install the PCIe card, he just moves this wire out of the way, slides the card up and under it, and that's job done. You know, it's my firm belief that we need more people who have jobs in the real economy. So less private equity, less corporate finance, less AI, more repair, more manufacturing, more goods that actually provide value to people, goods that create jobs instead of taking them. Oh, and if you didn't think AI was a bubble yet, then Mike Burry, who you may know from The Big Short, has shorted Palantir, and he shorted another company that's doing similar things. So I'm not an investor, and that certainly isn't advice, but if Mike Burry's shorting Palantir, then you better think twice if you're an AI shill. Not that I don't use AI occasionally, but, you know, we all do think it's overvalued. Cool, zip ties are cut. I'm not going to do anything with these wires, they're just sort of going to flop around in the case. Do you know what, I'll just chuck them in there, I guess. But this thing is ready to plug in and test. Just before we test the computer, let me go over what's been done to it. So we have a front fan, we have a rear fan. Obviously we have the CPU with a nice big heatsink, it's got 8GB of RAM, fresh BIOS battery. The motherboard is pretty standard except for the capacitor for the BIOS, and I did a lot of hacking and modding to this board a while ago, hence why that capacitor is like that. It's a long story. This is a TFX power supply with a 3D printed backplate, 3D printed I/O shield. We've heavily modified said power supply to put 7 SATA power connectors on it. I wouldn't go for any more than 7, but honestly, 7 is fine. It's not going to overheat, it's not going to melt or anything like that. I've done plenty of these mods before, and the hard drive's only actually consuming 3 and a bit amps on the 12-volt rail and 4 amps on the 5-volt rail. It'll be absolutely fine. We've got these 3D printed pieces here to facilitate the rest of the stuff, and I mean that should pretty much be it. It's going to be a busy case, but that's fine because we've got plenty of fans to provide good airflow. Now, if you don't know what openmediavault is, then you can go to this website, openmediavault.org, to learn more. But in a nutshell, it's a NAS solution based on Debian Linux. The idea being that you connect all of your hard drives, it just runs everything it needs to run out of the box. It's got smart, you can manage your volumes with it, you can have Wake on LAN, there's loads of plugins that are available. It's completely free to download and use, and it's maintained by volunteers. It's all open source, there's loads of features. I mean, you can pause the video if you want to read any of that stuff, but it's really, really powerful and it's very easy to use. I've plugged the SSD in off camera, and now that I've done that, I'm going to turn the computer on. And whilst it's booting, I'm going to press the F10 key a bunch of times because that will open Ventoy. You can see here, we've got the SSD showing, we've got the USB drive showing. I'm going to click the USB drive, and when it loads, we'll choose openmediavault. Then we'll just hit boot in normal mode. It's going to beep at us and we'll just say install. It's all done and it's now booting itself up. It's probably going to give me an error because it doesn't have any internet connected to it. But that's fine. I was just going to install the OS on my friend, and he's the one who's going to configure it and set it all up and so on. There we go, everybody. That's all I've got time for today, I'm afraid. You'll recall at the start, I wanted to show you how to install RAID 10, and I wanted to fit the drives in the box. But in my editing software, this video has already run for over 30 minutes. Concision never was my strong suit, so if I tried to do all of that, it would run for another 30. Instead, there's a 15-minute video in the description that covers everything that I want to cover. So, you know, if you need to see all of that stuff, then just go and view that. If you did find this video useful though it may have been a bit long, then please feel free to leave me a like on the thing. I'm not going to sit here and beg you to do that, but likes are the fastest way to grow the channel pretty much. It tells that good old algorithm that, hey, this person's putting out content people actually want to watch, so we'll boost his video slightly higher. Subscriber count increases. Suddenly we're reaching more people. We reach more people, we spread the repair message further. More people are keeping their own cash in their own back pockets, and that benefits basically everybody. The only people who lose out from that is shareholders, and well, you know, I won't lose any sleep at night knowing that. But if you would like to see where the channel grows, should I say where the channel goes, then feel free to hit the subscribe button. I'm at like 45 or 50 or something, you know. It's going to be a slow, arduous process. A bit like sitting watching this outro. But seriously though, I've got a video in the pipeline. It should be coming out in sort of 5 days, maybe a week after this one. I'm repairing a MacBook Air, something a bit different. I don't normally touch Apple devices, but it was given to me by a good friend, so I was like, do you know what? I thought it was scrap. Turns out it actually has some value, so I bought the parts and we're going to get it fixed. That's all I've got time for today though, so until the next time, I will see you later. Take care for now, and goodbye.